Hi guys, so I've finally gotten around to making my advanced terminal video. It's been sort of a long road for me to be able to do this. I just took a new job and so it's been a mess. So hopefully things clear out so I can make the next few videos soon-ish. Yeah, so anyway, Debbie and Buster is going to release sometime this year, I speculate. There is no hard date, but we are in a full freeze. I'm thinking sometime around August, so I'm hoping before then I can have the entire series basically completed by that point. We'll see where we go, where we get from there, but that is the hope. Anyway, so let's get into showing you guys some advanced terminal commands. I'm going to go pretty quick on this because my last few attempts at this video have been longer than I had hoped, and so I'm hoping that I can keep it a bit shorter. So let's dive right in. If you guys have more questions or anything like that on any commands I'm doing, use demand pages or use TACH help on any command. So, you know, ls TACH help to get help on your commands, or just man ls and you can get help. Not every command will have a man page, not every command will have help output, but usually they'll have one or the other, so you should be able to get help. Otherwise, Google the command. But generally, most of these will be able, you'll be able to find something on it. So the first command I want to talk about is cat. Now, I probably did this in my last video. I can't remember everything I did in my last video, but I'm fairly certain in my last video I just used cat to output some text onto the screen from a file. That is the most common way to do it. So I want to talk about that a little bit. So essentially what we have is I've created some files in this home directory here. I've got mess and I've got mess2. They're just two text files that have some garbage in them, and we're going to use that text in order to sort of understand how cat works a little bit. So normally you can cat mess.text onto the screen like so, right? And that will give you some output, right, onto your screen. It will basically output the text in mess.text to the screen, right? And you can do the same for mess2.text, so we can see what's in that file too. That's a couple of letters and a space, a blank line at the bottom. Okay, so now that you know what's in both files, here's the question, right? Why is it called cat? Why isn't it just like print or show or something like that? Why is it cat? It's because cat is being used for its sort of lesser function, I guess, most commonly, because most people just use it to print the contents of a file, especially new people, which is fine. You can absolutely keep doing that. It's a common use, and it's perfectly fine to do it that way. But cat is a little bit more than that. Cat stands for concatenate, and you can actually use it to concatenate files together. So if, for instance, I do mess star, for instance, like that, you'll notice that now it output the information from both files into one output. So that's really what cat's about. There's also a program you can use called split, which I'm not going to go into, but you can use that to split a file up into multiple parts. So if you have like a really big file, like a hard disk image or something, you can take split and you can use it to split that hard drive image across multiple files if you want to transfer it, for instance, over a really slow internet connection, or an internet connection that constantly fizzles or something, you know, you have latency, or you want to cram it all on a disk, or whatever your reason. You can split that file out, and then you can use cat to put it back together, and it's pretty cool. I'm not going to actually go into any of that right now, though, because I'm trying to keep this video a little bit shorter. So now that I've gotten into that, let's talk about pipes, so or command filters, as they are sometimes called, right? They're filters, pipes, whatever. You can use these things basically to extend a command, essentially. So you can take the output of one command and use it as the input of another command. That's basically what it does, like in a nutshell. So for instance, let's take this cat command here. Let's say we want to sort this information. So we can pipe this into a command called sort. And sort, by the way, is another command that takes all kinds of flags and stuff to do different things. You can change up your output quite a bit with it, a little bit with it. Man that out if you want, or TACH help. But I'm just going to do the basic form of sort because video length. So sort, and let's say I wanted to also get maybe all the unique lines, because you'll notice I've got some duplicates in here. That was on purpose. We got 2 9s, 2 7s, etc. So we can pipe that to another command called unique. and it will print only the unique lines. Now here's some information about unique. In the standard form of unique, it will only identify something is as unique if it's redundant. So you'll want to sort your information first, right? So if like the 9s were in different places in the file, it wouldn't have found those as unique lines. It would have printed both. If you sort the information first, you'll get truly unique lines. So that's a good way to do it. So that is how you pipe. So how many pipe levels can you do? How many layers of piping can you go? Well, I've actually never hit a limit. I don't think there is a limit. You can actually do it as much as you want. However, every single step you do, you're adding a little bit of latency, but that's probably not going to be an issue unless you've got like gigs of data that you're working with or something. But generally speaking, you can pipe it as much as you want. So that is piping, and that is the gist of piping. We're going to be using that a little bit more throughout this video in order to extend certain commands and show you, how to filter for information, because that's usually what it's designed for. Is you take, the output of one command, which has way more information than you want, and then you use the piping to cut that information down until it's more manageable. So let's talk about redirects. So redirects are a way to take output from one command and put it into a file or somewhere other than the screen. So for instance, if I wanted to take the output of cat mess star here, and I wanted to maybe put it in a file instead of printing it to the screen, I could put it into all.txt, right? So now let's look at all.txt. We can actually see that we have an all.txt in here. There it is. And if we cat all.txt, what do you think it has in it? Well, it's got that information from that file in it. You'll also notice that when I did that cat all.txt, it did not print anything to the screen. Why? Because we redirected the output of the cat to all.txt. That's essentially what we did. So that's redirection in a nutshell. But there are some nuances about redirection we should get into. Like for instance, the single arrow here will redirect all output to that file, but it's going to clobber whatever's in that file. That's literally going to take the output of that command, make that file, if it already existed, that output. That's it, right? So for instance, if I go into all.txt and I add to it a line, let's add testing 1, 2, 3, right? 1, 2, 3, 4. Sure, why not? Doesn't matter, right? And then I redo, well, we can cat it so you can see that it's there, right? Which we just added it, so of course it's there. Now if I do this command again, you'll notice that cat all.txt, that the command has overridden the file, right? Our text that we just added to the file is no longer there. So if I do echo something like this, right? Echo just echoes or just prints whatever you put in the quote marks. Since I'm putting nothing in the quote marks and I'm redirecting the output to all.txt, that is a clever way to blank a file out, actually, is what that is. So now if we cat all.txt, it should be empty, and it is. So if we add a line to all.txt, we'll add testing 1, 2, 3, 4. So I keep pushing 4 for some reason. My index fingers, my trigger finger's itchy, I guess. So if we cat all.txt, you can see that that information is now in the file. And now if we do a redirect, but instead of redirecting with the single arrow, we'll use a double arrow. What does the double arrow do? Well, it appends. So now if we look at all.txt, you'll notice that the information that we typed in earlier is still in fact there. So the append redirect is safer than the other redirect because it actually leaves the old information in the file. So one important thing you should know about redirection, never confuse it with pipes, right? Don't accidentally redirect the output of one command into another command, right? And the reason why is if you did something like this, and then, well, here, let's do it like this because it's just funnier that way. And then we'll do, I think it's user bin sort is where sort is. So if I did this command, it would override. Granted, it's not going to work because I'm not sudo. It will ask me for sudo. So be careful about sudo too, because if it unexpectedly asks you for sudo or for elevation, don't just blindly give it to it, because you may be doing more than you bargained for. And in this case, you would be, because this command right here would replace the sort binary with a text file that has the words hi in it. So probably not what you were intending to do. So definitely be careful and do not confuse redirection with piping. Another thing is never use the full path on your command. The reason why is if you enter a command that looked like that, if you enter a command that looks like this, what will that do? Well, it's going to create a file called sort over here, and it's going to have the word hi in it. So if I cat sort, you can see the word hi is there. So not giving the full path is actually safer because of that. So yeah, so that is an interesting little thing there to keep in mind. However, so there are a couple of different outputs you can use. There's standard out, right, and then there's standard error. So let's look at standard error, right? So what I want to do is I want to take TCP dump, right, and I'm going to use I here for the interface, and I'm going to give it ENS3, which is my interface. I'll show you how I know all that a bit later. And I'm going to redirect the error, standard error, which is 2 like that, and I'm going to redirect that to dump dump.error, right? So this is going to create a file called dump.error. Now you'll notice there is no error printed here. However, TCP dump did not in fact run or do anything. Otherwise it would have printed stuff to the screen. So TCP dump absolutely errored out. Why did TCP dump error out? Because you can't run TCP dump unless you're root. So I'm not root, so it errored out. It probably said it couldn't find the file. Why didn't it print it to the screen? Because standard error was redirected, and that error message would have come through on standard error. So where was it redirected to? Dump.error. So let's look at dump.error and see what it printed. It printed TCP dump command not found, just as I had predicted. So that is a way where you can capture the errors that you're seeing from a command and put them in a file for later review, instead of them just being on the screen where they'll get lost in the history of your bash somewhere. This is a way to sort of capture that. But that is only standard error. You could redirect both. I think you can do that with an ampersand. I don't know that I have a good way to really show you that though, but this should redirect both standard error and standard out to dump.error. So if we now cat dump.error, we should just see command not found. And if I echo, for instance, just to show you that it is in fact doing something, to dump, which should blank the file, right? And then I rerun our command here, and then I cat it again, you'll see that it does print command not found. If there were other output, it would print that as well, but because it's just printing the command not found there and then quitting, it's not actually giving us any normal output. But that's how you would, that's an easy way to redirect both. That doesn't necessarily work in all shells. There is another way to do it. You can certainly Google that one for yourself. But I think we need to move on at this point. But in Bash and ZSH, that should work. In modern Bash and modern ZSH, that should work. Let me rephrase that a bit. So there is another bit to redirection that I want to show you, and that is redirecting standard input, because that can be redirected as well. So let's take the command sort, for instance, right? And let's say we want to redirect from standard in all.text, and then let's output that to all_sorted.text. Now what have we just done by doing this? Well, we've taken the information in all.txt and we are using it as input to the sort command, and then we are taking that and outputting that to all sorted.txt. You could in fact use, if you wanted, the double arrows here. That's perfectly fine if you want to append rather than clobber. But if we do this, what's going to happen? Well, if we do cat all underscore sorted, we're going to get a list of all of the information in that file in alphabetical order thanks to the sort command, right? That's what we're going to actually get. What if we wanted to print only the unique lines? We could improve this by adding a pipe, and we could pipe unique. Now, don't confuse this, and make sure that you put your pipe on the right side of this command here, because if you put it before the sort, then it would redirect the input into the unique command instead, which would not be the desired outcome. So if you want to add stuff to this via piping, put it after this bit, right? So if you do that, what happens to your file, right? If you cat all underscore sorted.txt, now you'll notice that we only have unique lines in our all underscore sorted.txt. So input redirection can be combined with output redirection and also standard error redirection, or both redirection or piping. It can all be combined together in order to make some really crazy, wild, insane commands that will do really neat stuff if you're pretty smart and can figure out how to make it all happen. So that is the gist of some of the back-end stuff that you can do with some really cool commands. There are a few more things that you can do here, though. So the big one is T. What if I wanted to take the output of a command and I wanted to have it not only show up on the screen, but also capture it in a file? Well, that's what T does. It'll actually do that. It'll capture everything on the screen, but it'll also put it in a file. So for instance, if I take let's blank out and go. I don't actually think you need to blank it out. It's fine. We'll do this as cat dump. See what's in there. Oh, yeah, that's perfectly fine. All right, so let's make that TCP dump work. Sudo tac I TCP. Oh, I'm sorry, not tac I, just TCP dump tac I. And then let's do ENS3, which is the interface that I'm working with. And we will pipe that to the T command. And we're going to give T an argument. We're going to give it dump, dump dot, let's do dot text, because really it won't be errors anymore. Okay. So now this is going to give us this junk here, right? So it's just listening on ENS3. Nothing's really happening on this because it's a virtual machine, so you're not really seeing any activity. So let's generate some activity so that you can actually see what's going on. So if I go to google.com, and you can actually see as I'm typing activity happening here, because Firefox is searching live, so that ought to freak you out a little bit. But if I go to Google, you can see it doing more stuff too. So that's actually why I had that browser open, was just to do that. So I can use Control-C to quit that, and it will print, how many packets were received by the filter, how many packets were dropped by the kernel, all that good stuff. And you can actually scroll up and see the packet communication between this virtual machine here and the Google website, and you can actually see all the interactions between it. And if you actually save a TCP dump file out, you can put it into Wireshark and you can inspect it that way too. So that's kind of cool. And you can also add filters and stuff like that to sort this information or grab just the information you want. And I'll show you how to do that in a bit, because we're gonna grep for some stuff from this. Grep is a way to search, so we're gonna look at that. Let's look at our dump.txt file. So if we cat dump.txt, what do we have in there? Well, we have all the information that was just on our screen, because we piped that information into T and had T printed to both the screen and that file. If we had just done a simple redirect, it would have just put it in the file and we wouldn't have been able to see it on the screen. If we had done error redirection, we wouldn't have seen anything because there were no errors. So That is the power of T. Why is that important, you might think? Well, some commands are what we call interactive. TCP dump isn't really one of them, but some commands, like say apt-get, for instance, or apt in the case of modern Debian, modern Debian releases. Apt is interactive, unless you give it a switch or whatever to make it not interactive. But generally, it's interactive, which means it will prompt you and say, hey, do you want to continue, yes or no? Well, if you redirect standard output to a file and you're not getting any activity on your screen, you essentially cannot answer that question, and it's going to break your ability to actually complete the command. If you use T, then you can answer that question and still capture your interactions into a file. Apt is probably a bad example though, because apt basically logs everything, so you're fine if you get a var log and I think apt in there. So let's ls var log. You have apt, and then here apt logs pretty much everything it does. So I mean, it's not like you actually need to do that in some cases, but in other cases where you're installing stuff, or you're maybe trying to if you're trying to compile software or use make or something to do something crazy, then you can capture that output in a file and also see it on the screen at the same time, which is kind of convenient. So that's a cool way to do things. So let's look at our dump file, right? So our dump file has a whole bunch of stuff in it. You can kind of see it up here because I already cat it once. So you can see a lot of interaction between my computer and other stuff here. So you can see here we've got like a gateway. This is the virtual gateway. So let's actually grep for that. Let's do that. Let's show you grep with that. So a lot of people, new people, when they start using grep, I've seen this a million times where people do something like this. They cat dump.txt. Even I'm guilty of this from time to time because I'm on autopilot with it because I used to do it way back in the day. But you can cat this into grep like so, and then you can tell it what you want to search for. The quotes are somewhat unnecessary. Basically what the quotes are going to do is they're going to say if there's any special characters or spaces in the text that you're grepping for, we can ignore them and treat them all as one string. So we're going to do 192.168, and then we're just going to close the quotes, and what this is going to do is it's going to return every line from dump.txt that has those characters in it. So let's try that out. So now you'll see that only where those characters show up in a line are the lines printed. So there are much fewer lines. And we can actually pipe that to WC TACH L and get a line count. You can see we printed 56 lines that time. If we remove our grep, how many lines do we print? I wonder. We print 291. So you can use that to dig into a file and find information really, really quickly with grep. But however, this is completely redundant and you don't actually need to do it this way. Grep can actually take a file as input. So you can actually just do grep 192.168 and then you can pipe that. I'm sorry, you don't even need to pipe it. You can do dump.txt, right, like that. And it will still do it. And if we pipe that to word count, you'll see we still get the same number of lines. So let's do WC TACH L. So word count, I don't think I've talked about that yet in this video, is just a simple program that will print the count of a line, or the word count in a file. So it'll just tell you how many words there are. It's a cool way to find that information, although Vi will tell you and such. And I think there's even a way to do it with cat. But word count is the common way. You just pipe whatever output into word count, and it'll tell you that. But most people don't use word count by itself. They use it with the TACH L switch. And that changes word count, so it doesn't count the words, it counts the lines. So it just tells you how many lines there are in a file, essentially. Or in whatever you're inputting. So you can determine exactly how many lines you've just output to the screen, essentially, that way. So with this, essentially, we've got 56 lines filtered out, and we did essentially the same thing as we had with the cat in front of it and all that. So we don't need that. We can just do it this way. And that's actually the proper way to do it. Now grep, you can actually do a lot more with it. So like I think these are all going to start with 10, so maybe this is a bad example. But what I could do is I could grep for maybe the number 9 from all.text. And let's print that. So you can see it's printed 2 9s. Why? Because all.text, if I cat all.text, has 2 cases where a 9 is present. There's one and there's the other. So it just printed both of those lines. If there were more information on that line than just the number 9, it would have printed that too. Because grep prints the line with the information you're grepping for on it, which is very, very convenient. So yeah, that is a really good way to to find information in a file, specifically log files. Grep is great for log parsing. So another thing you can do here is you can invert match. So if you do attack I, attack I makes it case insensitive. Attack V is invert. So if I do an inverted match, you'll notice that it does not print any number 9s on this at all, but it will print all other lines. That's an inverted match or a reverse match. You can also do case insensitivity. So if you do that, normally grep is case sensitive. So if I grep a file for for A, for instance, it'll print the letter A. But if I leave off attack I, it's going to print nothing because there is no capital A in the file. So that is a way to make it case insensitive, so you don't actually have to know whether it's uppercase or lowercase when you're searching for it, basically. So that's probably enough of general grep stuff right now. You can obviously man page that. You can even do regex. If you do attack E, you can do regex and such like and get some really cool matching in there. But that's probably good. I want to move on so we don't spend too much time on just that stuff. So let's show you some really cool utilities that you should probably know about. So if you want to find out what USB devices are connected to your system, for instance, you can do ls USB. This is really great if you have like a system in a closet somewhere and somebody stuck a USB device on it and you want to find out about it and you don't want to get out of your chair. You can use that to do it. Mine's going to be really, really slim because this is a virtual machine, so I'm not going to have any USB devices really attached to it. So you just see the root hubs. But if I had like a thumb drive plugged in and mounted, which I'm not going to bother to do, it would show it there though. The next one is LSCPU, so you can find out some information about your CPU. These, by the way, all have switches and stuff, but this is the virtual CPU on my system that I've got here. I've got essentially 2 CPUs. Really, I think it's 2. This is done with 2 sockets. It really should be 2 cores, but it's no big deal. Anyway, so this is basically the CPU structure of the system that I'm working on, which is kind of cool to be able to see without having to crack your system open or look up specs. You can just, you can find it. This is a virtual CPU though, so it's kind of a little bit of a lie about what's actually installed in the hardware that's installed in the system. There's also LSMod. So LSMod will show you modules that are loaded into the kernel. What is a kernel module? Well, you can kind of think of it like a driver, essentially. That's sort of the gist of what it is. Now, because this is virtual, it's not going to show you any real good information. Like for instance, if you wanted to find out if your NVIDIA, your NVIDIA kernel modules were loaded, this would be a good way to do it. If you wanted to make sure that your video driver was essentially loaded like it should be, you could do this and you'd see the word NVIDIA over here somewhere. Same with AMD or Intel, for instance. You could do that. You can also use a program called DMI Decode, D-C-O-D-E, which you're going to need to sudo in order to run. It should be there by default, but you can install it if it's not. I'm pretty sure it's just apt install DMI Decode. But what is this actually showing you? Well, it's a whole bevy of information basically about your motherboard, essentially. So it'll tell you about memory modules you have in your system. It'll tell you what your manufacturer name is for your motherboard, what your model number is. If you have a serial number that's listed in your BIOS, then it'll tell you that. You can get SKU numbers, all kinds of information about your system. And the really cool thing about this is if you're used to, if you've come over from Windows, and you're an advanced user and you're used to using like WMI to output BIOS information without having to reboot your system and actually go in and check, this is the Linux equivalent of that essentially. You can go in here and you can get all kinds of information. There's a ton of switches for DMID code. Absolutely check that out in the man page, because you can print just particular sections in order to cut this down a little bit without having to come up with fancy greps to get what you want. So yeah, definitely look into that command. It is wonderful, and it is a huge time saver, and prevents you from having to crack your case open in order to figure out what all you need in order to understand what's in your system. Another really good one is LSPCI. I don't think I showed that one, and it's not on my list to show it to you, but I'm going to add it because it's amazing. So if I wanted to find out, for instance, what my VGA controller is, in my case it's a Red Hat, virtualized, para-virtualized thing. So if you have a big system with lots and lots of CPUs, like my real hardware that I'm running on is, you may want to grep this. So what you can do is you can grep, G-R-E-P, and we can use our TACH for case and sensitivity, and we can grep for VGA, and we'll get just our VGA controller. So that is a good way to understand what is actually in your system. If I was running an NVIDIA card, it would tell me it was an NVIDIA card. It would tell me the manufacturer number and the model number and all that. So if I'm running, for instance, like a 1080 or whatever, it'll tell me, oh, you're running a 1080 GTX in there. It absolutely will say that. It's fantastic. So that's good. So let's move on to storage. Let's look at some storage stuff. So the first command I want to show you is fdisk. So if we do sudo fdisk TACH-L, it will show all disks attached to the system. Now, special note, if you're using GPT partition schemes, fdisk isn't really the utility you want. You want to use something like gparted, but you'll have to Google that, or simply look up parted, man parted, or gparted if you're using I think gparted is the GUI version. I think parted is the non-GUI version, if I'm not mistaken. But anyway, fdisk is a way to look at your disk drives. And if you do fdisk TACH-L, you can see your disk drives listed, and these are your partitions. Now, note for fdisk, I'll show you more on fdisk in just a second, but first let's change directory into our dev, because you'll notice that all of your partitions reside in /dev. So let's go to /dev and let's see what it looks like. So in /dev, you can see a ton of stuff, which is probably not, that may look overwhelming to you, but it's not that bad. Okay, so let's break this down a little bit. Let's ignore pretty much everything you see here except for the SDA stuff, which I can't really select all of it. It's going to highlight everything, but whatever. You get the point. These are the ones we want right here, if you can see my mouse cursor bouncing around. So if you're running a virtual machine, you may see VDA. That is logic. That is perfectly fine. You may also see HDA if you're running an old machine, specifically with like spinning disk IDE stuff in it. But if you're running a fairly modern system and it's not virtual, or maybe it is virtual, it's probably going to be SDA. If it's virtual, it could be VDA. And it is possible to have both. If you've got dual hard drives, depending on the way they're mounted, you may see SDA and you may see VDAs as well. That's perfectly fine. Just be aware that VDAs can exist if you're running a virtual machine. So SDA, what is SDA? SDA is the representation for the actual disk. It is the entire disk, it is the disk in its entirety, right? SDA1, SDA2, and SDA5 there are partitions that hold information on the disk. It's like sections of the disk if you don't know much about storage. So let's take a look at some of those. So we can do fdisk, and we can do, I'm sorry, we're going to need to sudo that. Let's get rid of that. Sudo, get rid of that funny character there. And let's do dev SDA. Now, quick note about fdisk. Don't give it a partition. Give it the actual disk. If you give it a partition and you actually write changes, you can create problems for yourself. But it'll also give you error messages that aren't really real, and it can freak you out. So just make sure that you're never giving it a partition. Give it the whole disk, okay? Whole disk. So when you run fdisk on an actual disk, you'll get something that looks a bit like this. If we press M, you can see some operations that we can do. We're going to look at print the partition table because we want to actually inspect this disk. So now you can see that we have these SDA partitions, and here is the information on them. So you know, that's kind of what we saw already before, so this isn't really anything special. It's just a way to another way to look at it, essentially. Where FDisk shines, though, is its ability to change information on the disk. So you can actually create new partitions. You can, you know, you can fix your you can add a partition if you've got storage at the end of your disk or something, and you can delete partitions if you want to remove one. And you can also verify the partition table, and you can change the partition type. The partition type is kind of interesting, so that's the one I'm actually going to talk about. The others, you just do it. Now note, if you do make changes to this, it's not live, right? You're just queuing up actions. Think of it that way. Like you're queuing up a bunch of actions, and you're waiting for those actions to execute, and they will execute once you issue a W, which is a write table to disk and exit. And then depending on if the disk is your boot drive and if it's mounted or whatever, you may need to actually reboot to see those changes on the disk. So what we're going to do is we're going to issue a T, which is the type, and then we're going to do partition 5 because it's the default, although I could do any of them. And we're going to use a capital L here, as it suggests, to list all the types. Now if I use that capital L, you'll see that I have a whole bunch of types I can choose from. So this is going to be important if you want to take a partition and you want to say, I want to start using LVM on this, so I'm going to make this partition in LVM. Partition for, you know, to be an underlying partition for logical volume management, which is not normally the way I'd recommend you do this. If you're going to add another disk to the system, just make it a raw disk. Don't actually add a partition to it, and make that make that disk part of the logical volume, and then do it. We'll talk about logical volumes in another video, though. But for now, if I wanted to actually change this partition type to a logical volume, I would enter 8E here. Now I don't actually want to do that, so I'm not going to complete this command. However, even if I did complete it, it wouldn't do anything until I issued a W to write. But I'm just going to cut it off here just for the sake of cutting it off here. But just note that if I did change this, it would actually say logical volume instead of Linux swap. So I'm just going to use Control C to kill that command off. So anyway, that is how you would change the type of a disk in your system, or the type of a partition on the disk in your system. So FDisk is alright. It's good if you want to modify things, especially if they're old school things. Again, parted is where you want to be if you want to do newer stuff, but I'm not going to talk about that one because I have to look up too much of it, and it's just not, it's not something I use as often. I'm more into logical volumes now, which is a whole nother topic for a different video. So we're going to move on, and I'm going to show you some other cool ways to look at what's on your disk and how it's being utilized. So what if I wanted to see, FDisk, you may notice, told me about my volumes. It told me like sectors, and it did give me storage, so I know exactly how much storage each volume technically has. Like this one has 12.1 gigs, and this has 7.9, etc., and so forth. But it doesn't really tell me how it's being used or where it's mounted, anything like that. And that's really important information to know. So let's look at how you can find some of that out. Let's look at a command called LSBLK. This wasn't actually available on older Linux distros, but it is a fantastic way to look at your stuff now. So you can see here, this is actually telling me I have a volume SDA, and it has a 20 gig total size. And underneath that volume, I've got some partitions. And you can see it's got a tree structure to kind of lay that out for me. And over here, you can see this partition is 12.1 gigs, and it is mounted as root. So basically, it's a one disk system, essentially a one partition system. Everything is mounted on as root. There is no /home. I did it that way because this is a virtual machine, and I don't care about it. But standard Linux practice says you should probably break out at least home, but you can also break out other things like temp and var and such in order to protect root from getting too full. But the reason you want to at least break out home is if you need to format your system, you don't lose your home directory, which is kind of important. But anyway, that's going off topic a little bit here. Let's talk a bit about this command. So this obviously has switches, and you can do different things with it, but really this is kind of what most people would use it for. They just type LSBLK, and they can see where things are mounted and what storage they're taking up. This command, FYI, will also show you logical volumes. If you have them and if they're mounted, you can see logical volumes with this command, so that's really cool. So if you didn't know about that, add that to your bag of tricks because it's a good command to use. Another way to look at your disk and utilization and such is df TACH. TACH just makes it human readable. df, you can issue it by yourself, but if you do, you'll get bigger numbers and it'll be in like bits or kilobytes or something instead of megabytes and gigabytes. So it'll just be harder to read. TACH, you can think of that as human readable. But you can see here that I've got my dev SDA1 and it's mounted with, it's mounted to root. It's got 12 gigs. You can actually see utilization here, which is nice. You can see that I've got 8.2 used, I've got 3.1 gigs available, and I've got 73% total utilization on this disk. So that's a great way to say, I'm using this much information on this disk. Maybe I should consider upgrading it. Maybe I should, I'm looking for a disk that has storage available. I've got logical volume set up, and I want to make sure that I want to, shrink one to grow another. You could look for the disk that's a good candidate for shrinking, provided it's ext4 formatted and not XFS. XFS cannot be shrank. And if you're using ZFS and all or different file systems, then that's sort of outside of the scope of the video. I'm not even going to talk about those in this one because that's just too much. So the other one you can do is DU. So let's go to our root. Let's do it in home, I think. Let's do DU TACH. DU is disk, is you can think of it as directory utilization, which I think that may even be what it stands for. But anyway, what it's showing me is all of the directories underneath my home directory and what they are using in storage. Now, as you can see, that is clearly way too much to look at. I could do things like grep for Steam and find only the Steam directories, which is cool. That's not a bad way to do it. But there is a better way where we can, where there's something we can do to mitigate all this gnarly output, right? So we can actually add TAC max TAC depth like so and put equals 1. You can also give it a 2, a 3, or 4 for however much you want it to max out at. But this will make it so that it returns a bit, something a bit more manageable. This is only showing the directories in the home directory and their total storage. So everything in Steam, for instance, is 1.5 gigs instead of showing me, Steam 10 foot and Steam, this, Steam that. Why I have Steam installed on a virtual machine, I think it was for a video that I did in the past showing how to install Steam on Linux. I'm not sure. I can't really remember. But anyway, so that is how you can determine how much storage different things on your system are taking up. Let's talk a bit about networking. So there's a command called IP that has replaced ifconfig. In Windows world, that would be ipconfig, right? Ifconfig was the old way to do it, and normally you would just type ifconfig. Is that even a thing now? Config. Let's try it with sudo. Yes, so it's still a thing, but it's outdated. Don't use ifconfig anymore. Instead, use IP, IPA specifically. A stands for all. You could actually type all out there, and you'll get the IP address of the system that you are working on. You can see that's this 122.8 on this virtual switch here. So this is basically the gist of how you get IP information on your system. You can also see MAC address information. So here's the MAC address for this particular network interface. And you can see that it also will provide you with IPv6 information if you have IPv6 enabled. This is just enabled for demonstration purposes basically here. I am an American, so we're still dumb and not using IPv6. Sad panda, right? So anyway, so that's IP. You can do a lot more with IP, like you can bring interfaces up, so you can do IP, let's see, IP, you can do IP link show, you can do IP link ENS3 show, I think. Nope. Maybe you can add it at the end, I think it is, ENS3. Yeah, so you can do things like that to see just the link. I think you can do IP link set ENS3 down. I'm not going to do sudo for that, and that will bring the network down. So now if I do this show command again, you'll see that it is down. And you can actually see the network has disconnected. So if I tried to go anywhere on Firefox, this would not function anymore. And I can set that up to bring it back up. And you can actually see it already happening there, but if I show it, you'll see that its state is up now. And if I did, sudo dh client, if you give it a TAC R, it will essentially release the IP, but it might not release the IP. It destroys the lease essentially. So if you want to try to get a new IP address, that'd be a good way to do it. And then you do ENS3. But if I look at if I do IPA, it's probably still going to have the old IP. Oh, actually, this time it did lose the IP entirely, so that's cool. But yeah, so R basically destroys your lease. If you do it without that command, it will renew the IP. So if I do that, you'll see now that if I do a show, oh, I'm sorry, I need this one. So you'll see that the IP has returned. And because the virtual switch is configured to always give it this IP address, it's going to always get that IP. So yeah. Anyway, so that's basically the IP command. That thing will do a ton of stuff. You can even use it to add like fake IP address or fake port or fake interfaces and all kinds of stuff. So IP is an incredibly powerful command. You should absolutely Google that, look into it, man it, whatever you need to do in order to learn more about it. I'm only going to touch on it because this video will be literally hours long if I go through all those little rabbit hole pieces. And the goal of this is just to kind of show you some commands that you can look into to be a better Linux admin. So the next one is SS. SS essentially replaces netstat. Netstat is the old way to look at open ports, essentially. I think SS stands for show sockets, and if you just use it by itself, it's going to show you every socket on your computer and what they're listening for and their status and everything. So that is sort of the raw output, which is a gnarly, unholy nightmare of information that you probably don't want. But you can add some switches to it. So if you do TACT, for instance, it'll show you TCP. If you add a U, it'll show you UDP. If you add a 4, it'll show you only IPv4 stuff. So this will actually knock it down quite a bit. And you can see that there's only one port that it's talking to, and that is an HTTP communication via Firefox, most likely. We can actually do in, and I think P, I think it'll show the process name. Yep, there it is, Firefox ESR. So N, I think, translates numbers. I don't remember what N does. Oh, N, I think, resolves the addresses to just their IPs, I want to say. I don't remember. You can man it out. Anyway, there's also 6 if you want to see IPv6 stuff as well. Drop that. Let's get rid of this stuff here too. Let's do TU6. It's not showing the IPv6 stuff, so that's kind of weird. Because it should, but I guess I don't have any IPv6 stuff listening at the moment. I don't know. But it should show IPv6 stuff. I think it was earlier. Weird. Yeah, maybe I just killed the IPv6 somewhere along the way. I don't remember doing it, but TU6, it should show 6. Huh. Well, now it's not showing anything, is it? That's strange. IPA? Yeah, it's up. Well, it should be there. I guess I just don't have anything listening. That's probably true. So let's go ahead and close Firefox. We don't need that open anymore. So that's that. There's also TCP dump, which I touched on earlier. Essentially, you can use that to dump the activity of your network card. So there's a lot more to TCP dump. So if I do sudo TCP dump TACI is the interface, ENS3, it'll show all activity across ENS3, and you can actually inspect the packets and determine what's going where, and you can filter that out a lot more, and you can find just specific packets on a specific port routed to a specific system. I mean, you can get really fine-grained with TCP dump. Absolutely recommend you guys look into that. It's a lifesaver when you're troubleshooting network issues. But we don't really have time to go into the ins and outs of TCP dump. That would be a video unto itself, maybe even a series of videos unto itself, to get that really sort of a deep dive into that. And maybe I'll do that at a later date. But for now, let's move on to process management, and the first one is top. Yes, there is HTOP and NTOP. Those aren't installed by default, so I'm just going to show you guys top. If you want to learn about HTOP or NTOP, you can install them and see for yourself. They're just kind of fancier versions of top. So top has your load averages up here. Your load average, I think, is 1, 5, and 15 minutes or something like that. I want to say. Basically, these are good numbers. If your load average, essentially, good load average is you want to look at your load average number and the number of cores you have on the system. So if I press the 1 key here, you can see I have 2 CPUs on the system. So I would take the number of the load average and divide it by 2. And if that number that is resulted is bigger than 1, you're going to have wait time on your system, essentially. It basically means there's going to be a process waiting for something to happen, waiting for resources. Is the way I was always taught. Basically, you want to take the load average number and divide it by the number of cores on your system, and if that number is bigger than 1, you have a problem. Take that with a grain of salt. Anyway, obviously you want your load average to be relatively as low as possible, but having it completely zeroed out basically means your system isn't doing anything, which probably isn't serving you a purpose. So, there's a balance there. There have been some really, really great videos on load averages and really understanding them. I highly recommend you look into them. I don't want to deep dive into that right now. I do want to note, though, that if you press the M key, you can change the memory, and you can actually see, memory utilization is a graphical representation. You can see it with like a solid bar, and you can just completely remove it from the equation, and you can bring it back. And I'm just pressing the M key each time to cycle through those. So yeah, and if you press the H key, you can see that you can actually do a lot of stuff with it. And I think also top does have some command line arguments. Press Q to get back to this, by the way. And then top, I think, does have some command line arguments that you can use as well in order to see more information. But this is actually showing me just the top processes that are running, hence the word top. The top most utilizing processes that are currently running, which of course KWin, the GUI, would be the thing to do it on this one. And if you want to look at memory and how much memory total memory your system has, you may notice that top is not a very good. I mean, it's kind of showing you this gnarly number, and you got to do math to figure out, where you're at, and that's fine. I mean, I think it's about 8 gigs, but let's see exactly how close we are. So we can use the free command, and if we add a TACH for human readable, much like some other commands we have, you can see that yes, in fact, we are at about 8 gigs, and our swap is also at 8 gigs because reasons. And we have about 6.7 gigs available. So that is good. So free is not necessarily correct. Buffers plus cache counts as available. So the real number you want to look at is available. Older versions of free show this a little bit differently, but just note that Linux is not munching your RAM as most people think when they see top and they see free and they're like, oh my god, where'd my RAM go? It's just caching, guys. I mean, it's fine, right? Like I remember when Windows Vista came out and Windows Vista implemented a RAM cache, and everybody freaked out because they thought their RAM was just gone. And I'm like, who buys a system with 16 gigs of RAM and then wants 16 gigs of RAM free? What's the point of having all that RAM if you're not using it? If you're not utilizing your RAM, then your RAM's essentially not helping you and it's not doing anything for you, and you may as well not have it. So don't be afraid of high RAM usage. It's not that bad, right? What's really bad is when the RAM is mismanaged. So for instance, if you have high RAM usage and RAM isn't being cycled to stuff you're actually using, then you're going to notice some latency, right? There is a gray area. There's an area there where you want to be in kind of a range, right? You don't want it completely maxed out, but you don't want it completely empty either. If you don't see some RAM usage, it means your system is essentially not doing anything, and therefore it's not serving you any purpose, right? So there is a middle ground. RAM isn't all good or bad. It's kind of, you got to feel it out. It depends on how much RAM you have available and what you're actually trying to do with your system. If you have a flashy GUI and you want a flashy GUI and your RAM's all eaten up by your flashy GUI, but you still have some available to run the programs you want, you're not doing anything wrong. If your system is running really sluggishly and you notice your RAM is constantly maxed out, you might want to consider killing some processes or switching up how you're doing things, or maybe installing another RAM stick, right? So that is how you can monitor, view, and understand your RAM. Now, in addition to that, there's also how do we kill processes. Well, top actually has the ability to kill processes. So if you look at top and we press K, you'll notice it says PID signal to kill. And I can actually type in one of these PID numbers here and kill it. This is probably the worst way to kill a process. Let's look at some better ways of handling this. The old school methods were kill, which you'd need to find the process ID with in order to know what it was, and you'd have to kill it that way. So you'd find the process ID with PS traditionally, so you could do AUX for instance, and you could see all the processes running, and you'd scroll through and maybe grep for what you wanted. So if Firefox is running, for instance, let's open Firefox again. Actually, you know what? Let's open something smaller. Let's do Kate. Kate's really small. Right, so we'll open that, and you can just see it up there in the corner. Just keep an eye up here, and you'll see it. I could pin it to the top, but I don't want it to override what's in the terminal here. And now, if I wanted to find that, I could grep for Kate. And, oh, lol, I accidentally launched it. And I totally just said lol like a tool, but it's cool. So grep Kate instead. And you can see that there are... there's this thing, which is the temp file for it. I think these are bin Kate. I don't actually know why there's two of these. That's really weird. But anyway, this is the PID, and this is the PID. Oh, yep, I do know why. So this is the grep that I issued. Grep Kate was a process that matched at the time. So that's why there's two. This is the actual Kate. This is the one we want to kill, right? I'm not actually going to kill it because there's a better way to kill it that I'm going to show you in a bit, so I'm just going to leave it open. But just note, that's how you get the PID number, and then you do kill, and then you would enter your 4047, and you would kill Kate. That would work, absolutely. Note there are two ways to kill things. There's 15, right? So actually, I am going to kill it. Kill, TACH 15, Kate. Actually, in this case, you have to do 4047. That's kind of a gnarly process. Who wants to do that, right? So 15 you actually don't need to enter. That's implied. So if you just do kill 4047 like that, that is how you kill a process normally. And it will imply 15 and the process will die. So if I press enter, Kate's going to go away. You saw that in the background there, I hope. So if I launch Kate again, the PID ID will have changed. So let's get it back. Now you can see that Kate is actually at 5854 now. Because it got a new PID when it reopened. That's fine. So let's say Kate refused to die. It just did not want to die. Nothing about it. It was just being a stubborn pain in the butt and it just didn't want to quit. What you could do is you could do this. That's a TACH 9. And then you can issue the 5854 command or PID number here, and it will kill Kate in a ruthless way. So what's the difference, right? 15 waits for the system to free its memory and do all its final terminations and shut down nicely. It's basically the same as hitting the X button. You know, it's like, okay, I want you to shut down, please do so. And the program's like, all right, let me take my time and get it right. 9 is just shut down. Just kill it outright. What does that mean? It means you could lose data. You know, if things aren't saved properly to the disk yet, whatever final terminations that the program needed to run in order to shut down properly, they're not being run. So, in essence, use a TACH 9 only when you need to. If your system is hard locked up and you can't get, you can't get any activity from that particular application, it just refuses to die, and you for some reason don't want to reboot or whatever, use a TACH 9 to kill it. But just know that it's not always the best idea to use a TACH 9. It can cause data loss or data corruption in a file, or it can have some negative side effects. So be a little bit cautious with that, and just generally just use it when you have to. Now, having said that, I use TACH 9 all the time when problems arise on various systems. If somebody's overtaxed something and I just can't get it to die fast enough, I need to bring the system back up right away, kill it, But always try a 15 first is what I'm saying. You use 9 as a last resort. Okay, so that is the normal way to kill things. That's the old school way of doing it. That is the way you probably shouldn't do it, but I wanted you to have that background anyway. There's another command that you can use called kill all. Kill all will kill all processes that share a name. So if I had 2 or 3 instances of Kate open, I could issue a command like that and it would kill every instance of Kate. That is also an ancient command, and it behaves differently in Linux and Unix than it does in Unix, per my understanding. So maybe not the best idea. There is a better way. So the best way to manipulate processes, the way that I prefer to do it, is I prefer to use a program called pgrep. It is there on most modern distributions. I would suspect all of them, though I haven't fact-checked that, so don't quote me on it. But it's definitely there in modern versions of Debian, and I'm pretty sure it's there in Red Hat and other distros like that. Yeah, it's definitely there in Red Hat. I've used it in Red Hat lots. So you can absolutely use the pgrep command, and we can grep for Kate. You notice it'll output a number. What is that number? Well, it is the PID ID. But let's say we output a bunch of stuff and we want to make sure we're getting the right one. We can add a tag L and it will list out the name Kate next to it. There are more switches to this as well that you can do and get more information, I believe, in there as well. You'll have to man it, but that's the most common one that I use. Normally I do it like this. And the reason I use pgrep is to double check that I'm going to kill exactly what I think I'm about to kill, right? So if I want to find the, Kate, I notice there's only one instance of Kate, so when I do pkill Kate, it will only kill one thing. If there were more instances of Kate, it will absolutely kill them all. So let's launch a couple of instances and see what happens, right? So now we've got 3 instances of Kate open. Let's issue pkill Kate. For some reason that one didn't die. I am unsure why that one didn't die. Stubborn little guy. Apparently it's got a different name somehow. That's kind of weird. So let's use the old school way. That's interesting. Huh. I do believe that process is, yeah, there it goes. Okay. So I think what was happening there was the process had been killed, but the GUI hadn't caught up yet. I'm not really 100% sure. Just note that the performance on a virtual machine is not as good as the performance on real hardware, so there may have been some lag between killing it and the GUI going, oh yeah, I should stop drawing that. But clearly that process didn't exist, so it was definitely dead. There is a concept called zombie processes where a process hasn't died yet. I think I maybe did that in a different video, I'm not sure. But if not, I will do it in a future one and talk a bit more about zombie processes. But this is essentially the best way to kill something is use pgrep and pkill. Now note the pkill you can bite off more than you bargain for, right? So if there are lots of programs named a certain way and you do pkill, with a partial name match, so for instance, if I did pkill and then ate or kat, and there was a different program that also had those letters in it, it would kill that too. So always do a pgrep first to make sure you're not biting off more than you can chew, because you might accidentally kill more things on your system than you really understand that you're killing, and you could cause it to become unstable, or you could kill stuff and lose data that you didn't intend to kill. So that's probably important to kind of keep in mind. So the next thing I want to talk about, and this is going to be controversial because everybody in the room will probably hiss if you are old school Linux users who don't like change, systemd. So systemd is pretty much on all modern Linux distros, with a handful of a few holdouts who just, for whatever reason aren't switching to it, or one of the modern distros who forked from Debian in order to maintain Debian without systemd because reasons. There are various reasons why people don't like systemd. Some people say that eventually it will include an Office suite, and there's a whole lot of negative connotations with it. But it is what's on Red Hat. So if you go into the corporate world, you're gonna need to know systemd. Like, you're shooting yourself literally in the foot if you don't. And it is on modern Debian distributions. And to systemd's credit, Debian runs perfectly well with it. Mine tend to be very stable. They boot really quick. They actually are faster and more stable than they ever have been. They suspend to RAM better, so when they go into sleep mode, they come up a lot better and more reliably than they ever did on sysv. They boot faster, so For everybody's complaining about systemd, I'm not really seeing as many problems. I'm sure there are problems, like you know, I was reading about a boot issue that was occurring because of the way systemd does randomization of memory, or some sort of random feed at the beginning of the boot process. Yeah, I agree. There's going to be issues. There'd be issues with anything. You know, so I'm not saying systemd is perfect. I'm not even saying it's what we necessarily should be using. I'm saying it's what we are using in most Linux distros now, and you're kind of doing yourself a disservice if you don't at least know a little bit about it. So today I'm going to teach you a little bit about it. If you don't like systemd and you don't want to use systemd, skip this part of the video. You're free to do that. The video has a little, you know, slider where you can do that with, so feel free. Otherwise, let's learn a little bit about systemd. So systemd, there are several different services in systemd, and note that systemd is absolutely modular. In other words, it works like any other Linux program in that you absolutely can use part of systemd without using the rest. So for instance, you don't need to run the network part of systemd, networkctl, in order to run systemd. You don't need that. You can actually just run the bare minimum of it, and that's perfectly fine. It's modular. You don't need all the parts in order to run it. However, you can absolutely run the complete package if you want. That's, you know, up to you, or whatever your Linux distribution chooses when it builds. So today I'm going to talk about 3 systemd commands. The first one is systemctl, the second will be journalctl, and the third one will be hostnamectl. Those are the 3 that I use most commonly. There are other ones like timectl and timedatectl and etc. and so forth, and there's also a way to like mount hard drives with systemd and crazy stuff like that. I'm not going to go into all that. I'm just going to basically talk about systemctl, journalctl, and hostnamectl. So systemctl is sort of like service management on your system. So if you do systemctl TACH, what is it? List TACH units, I think. And then you can scroll through. You can actually see various units on your system. These, you can think of them as well, they are, I mean, you can see the word service after each one. So they're services essentially, right? So you can think of them as like Windows services essentially, or daemons if you pronounce it daemons. And you can use this to sort of see which ones are running, which ones are exited, etc., and so forth. So it's sort of like service management. KDE has a program that you can use to actually view your systemd stuff and manage it in a GUI sense, but this is a terminal video, so it's outside of the scope. So with systemctl, you can, the most common thing to do is to like restart a service or to stop a service. So for that you would do systemctl restart if you wanted to restart one, and then networking, right? Networking. And this would restart the networking service on the system. And you'll need root to do it, so let's do that. And then you'll notice that that networking has presumably restarted. You can do status to check its status, so you can see that it's active. And then you can also do stop if you want to stop it. So let's go ahead and do that. You can see stop, right? I need to give the sudo command with this. So now if I do status actually doesn't need sudo, but you can see that it's now inactive and dead. So you can see that. You can also see this word up here. This is enabled. You can absolutely disable a service. So let's do that. Let's start preceding this with sudo though, so it stops prompting me. So if we do disable, and then, so what I've just done is disabled networking on this computer. So now if I do status, you'll see that it says disabled, and that means the status will not start, or that service will not start automatically with the system. So if I wanted to enable it, let's actually try to start it. Dang it. I keep forgetting sudo. I think I fat fingered the password there. So now you can see that the status is enabled, or the status is active, but you can see that it's still disabled. So starting it does not enable it. but you can start a disabled service, right? That seems confusing. Essentially, that means I can start a service, but when I reboot the computer, it's not going to come up automatically. That's what it's essentially saying, okay? So if I wanted to enable it again, I would use the enable command. And I'm going to type the password again. There you go. Okay. And now if I want to do status, you can see that it is, oh, it's disabled still. Enable. There you go. Now if I check the status, you can see that it is in fact enabled. So that's how you enable, start, and stop services. Enable, disable, start, and stop services. Those are the most common commands of systemctl. There are others. You can obviously man page it, Google it, whatever, in order to find out more. And I highly recommend you do so because there are some really cool things you can do with it. So let's look at journalctl. If I do journalctl and just press enter, it's not going to give me anything. It's just going to tell them, I'm not seeing any messages. I'm going to need to actually give it sudo in order to see the actual stuff. Now this is just going to fat output whatever it has at the time and just give me everything, which is probably more than I want. So I'll show you how you can filter that down a little bit. So if I just do TACH B, it'll give me the last boot that occurred and just those lines. If I do TACH list TACH boots, it'll show me the different reboots that have occurred recently, and I can list just those. So if I did this, for instance, it would list just the first boot. Because it's the only boot, you're not really going to be able to differentiate that, but because if there were a second boot in there, I haven't rebooted this machine recently, so there just isn't. But if there were, I could give it a TACH 1 or TACH 2 or however many there were, and it would show me those boots only. So the old way of doing logging, right, is you would go to cd var log, and this still works, by the way. So like if I wanted to log messages, right, so if I wanted to look at messages is probably quite big, so if I don't want to just look at it, I would use the tail command, tail, and most people would give it a number, maybe TACH in 50, and that would show the last 50 lines of messages, right? Oh, and we got a sudo up, of course. And you can see the last 50 lines of the messages file there, right? But let's say I wanted it to log constantly. I could give it a TACH F, right? TACH F, and you'll notice that it doesn't return. If more things happen, like say I open up another terminal, for instance, and maybe sudo up. Okay, it's not printing that in messages. So maybe let's look at off. Okay, and let's exit this. Okay, you can see that it generated a new thing down there. Can I do this? No. Okay, it's fine. Shrink this terminal here. Okay, you can actually see it exited that. So if I do another one, right, and do the password to the system is password. If you were wondering, I thought it was going to prompt me again. So I was on autopilot a bit. But anyway, you can see that it opened another session. So basically what TACH F does is it gives you a constant feed for that particular log. The TACH in gives you a number of lines. So that's tail, right? You can do the same thing with journalctl, except you don't have to worry about, CDing into this directory or whatever. You can just simply be from anywhere on your system, and you can do journalctl, right? So journalctl, TACH F, and then it will just give you an output. Oops, got a sudo up though. And it will just give you a constant stream of output. So now I can quit this, right? If I exit, you can see that it prints that line, right? Close for root user, and I can do it again, and you can see it open for root user, and that's exactly what we can do, right? So that's pretty nifty. So the other thing we can do is we can show all messages by a specific executable or by a specific unit. By a specific executable, you can actually point it to the executable. So if I come down here to journalctl and I do like user local, or not user local, sorry, user bin, what all do we have in there? Probably a lot of stuff. What's a good one? Oh, you know what? Let's do it like this. User lib system D system D. That, by the way, is actually where it's located on your system. Well, supposedly anyway. Maybe I'm misdoing that. I may have fat fingered something. Nope. Okay, user bin. You know what? Let's just do this. ls user bin. This will give us some stuff we can look at. I think sudo's in here. So maybe we can do like this. User bin sudo. Is that in there? Yes. So this will show me all the information for sudo, right? So you can see it's all the sudo stuff just broken out. So that's how you get specific information for a specific executable, right? So if I wanted to get it for a specific service, though, I could do journalctl and then TACH u, and then I could do networking, for instance. And that'll show me all of the information that has occurred about networking, basically where I started and stopped the services. So that is essentially how you use journalctl. That's some of it, which is pretty cool. I think that's a good method to manage journals, because you can do it from anywhere on the system. You do still need to use sudo, but you don't have to cd into directories and stuff like that in order to find your logs. You can just do it from anywhere. So that's kind of nice. I'm not going to say it's better necessarily. I mean, sure, there's ups and downs of both, but it's pretty cool. So let's look at the next thing, which is hostname.ctl. So you can still do hostname, which is the common way to find out your hostname. I mean, other than just looking at the second part of your prompt here. But you can do that if it's not in your prompt for whatever reason, or you just want to see the hostname of the system. I believe you can do, I think there's a way to show the fully qualified if you do, like, let's see, is there a TACH H for that? TACH help, maybe? Yes, so yes, TACH F. That's what I thought it was. So TACH F will show you the fully qualified, which this is the fully qualified because this is just a virtual machine, and I didn't give it an actual domain part of the domain name. That's how you see the host name. But if you want to set the host name, it used to be you had to go change stuff in a file and do all kinds of stuff. Now you just do hostname.ctl. Hostname.ctl, TACH set hostname, I want to say. I don't do this very often, so yeah, it's actually not TACH. It's just set TACH host name, like that, and then you give it a new host name, so new name. And it would set the host name for this system to new name, essentially. I think you still have to log out, log back in to see the changes in your prompt, but you know what? Let's try it. Yeah. So now if I drop this, I think maybe if I do a new instance, it will show it. But let's see. Yeah, so you can see that it's changed the host name. So that's a really nice, easy way to change the host name. Let's go ahead and set it back. There we go. And now we get that. Another thing that's really cool about this is it does in fact integrate with KDE sudo, and I think the GTK sudo, GTSU or something like GTKSU maybe. So essentially, if you don't enter sudo and elevate to root, it will prompt you for that information. So it doesn't just fail; it actually gives you the chance to enter it in, which is kind of cool. I think that's neat. Yeah, so this gives you the power to change the name of your system. Which is kind of nice because it's a bit more convenient, in my opinion, than the old way of doing it, which is kind of a pain. So the final thing I want to show you guys is SSH and how to use it, because remote management of systems is critically important. And if you're running any kind of server farm or you're working for anywhere that has servers, you probably have headless systems that you can only SSH into. So knowing SSH is critical. If you don't understand SSH, you're not going to get very far in the corporate world. So at least as an IT person, right? So let's talk about SSH a little bit. So SSH, essentially, in order to SSH to a system. Now, I can't actually SSH into another system on this box because there is no system out there listening on this virtual network. It's just this one. So I can only show you theory, but you'll get it. It's fine. It's not that bad, right? So let's do SSH. So what you can do is if your username on the remote system is the same as your username on your local system, you don't need to enter this first bit. But if it is not, you can do this. User, where username is a placeholder for the username at, and then the actual remote system, so host name, or you know what, remote, R-E-M-O-T-E, system, there, remote system. So that will actually SSH you, the user, into the remote system, and it would prompt you for user's password at that point, right? That's how it behaves by default. Now you can do more with this. So if you look at, let's say you want to SSH with like keys, if you want to generate a key pair and then SSH. That is actually probably the most common way to SSH. Most people will, well, in the corporate world anyway, you want to use keys. They're more secure, they're just better for everything. So let's take a look at how to do that. So if you look in your CD into your .ssh directory in your home directory, if that doesn't exist, don't worry. It'll exist in a minute. You'll notice that there are some files in here. So I have an authorized keys file, a config file, and an IDRSA and an IDRSA.pub. These may not exist for you. That's fine. Okay, that just means you haven't done anything yet. So let's back out and let's do some things. First, we're going to generate your key pair. So let's do SSH TACH keygen. Okay. And we're just going to override the keys that are there because I don't care about them. So yes, in your case, it probably won't prompt you for that, and it'll give you some other questions like, you know, do you want to set a password, this and that. If you're doing this in a real setting and not just a fabricated setting like I am, please set a password to your key. You don't want people impersonating you, and that's the best way to stop it. So anyway. Once you've run your SSH keygen, you should get those two files in the .ssh directory. So you should see basically just these two files. You may have some more stuff in there. You may have less stuff in there than I have. That's perfectly fine. I'll show you about the rest in a minute. Okay, so that is your key pair. This is your private key. This will never leave your system. In fact, if it ever does leave your system, you should consider it compromised and you should generate new ones. That's the way that works. This never leaves this one system that it's on, ever. You generate it on this system and it stays on this system. It doesn't go to any other accounts. It doesn't get moved out of this directory. It sits right there and does not move. All right? Otherwise, it's compromised and you need to make a new one. Okay, IDRSA pub is your public key. This one you can send anywhere you want. Put it all over the place, anywhere you want to log into. Speaking of that, your remote system will have this authorized keys file, right? That's actually on the remote system you want to log into normally. I made it here so that you guys could see it, but generally it's on the remote system. So if you do SSH TACH copy ID, like so, then it by default will copy this to the remote system's authorized key file. So you would give it the remote system name, so remote system, which, by the way, just a side note here, this at remote system bit, this can be a host name or it can be an IP address. An IP address is perfectly fine. In a corporate setting, I hope you're using host names and not IP addresses, but you can use IP addresses if you're, you know, a caveman. So SSH copy ID remote system, which actually that should probably be all one word, whatever, would copy the ID onto the remote system. This would be the host name or IP address of the remote system. That's a placeholder right there. So that will do that. And you can also do, this is just SSH, so you can do user at as well if your usernames don't match. And that will allow you to copy your pub key essentially to that. There's also a way, if you man it out, to copy different ones. So if you have more than one key in here that you saved. So if you change the name or whatever, because you can enter a file when you generate your key. If you change that, you can tell it specifically, I want this one on this system and that one on this system or whatever. And so that'll be a good way for you to manage your keys. Also, you can do, you can just copy and paste, the key. So if you do cat and then id rsa.pub, you'll get this output. If you take this and you copy it, and then you go to your authorized key file on the remote system, right? So if I do vi authorized keys, just to show you what it looks like in here, and you just paste that in there, which I did with Control-Shift-V. Depending on what system you're on, that may differ, but most Linux systems, Control-Shift-V will paste in the terminal. So now anybody with that key, i.e. me, because I'm the one who generated it and it's never going to leave my system, can log into this system, and that will allow them access. So essentially, but there is no SSH server on the system, so that's actually not going to work, and I can't demonstrate it, and I'm not going to bother setting it up. So, but just note that that is one way of doing it. So, and then copy ID would obviously do the same thing, but like some systems, for instance, they have the ability to log in via password disabled entirely, and if that's the case, you're going to need to like send that key to an admin who has access already, and then he'll put it in there for you. Or if you have like Ansible or Puppet, you can configure those to automatically put the key in for you. There are many ways to get the keys in that file. The gist of it is you want your key in that file. If it's not there, you can't log in. If it is there, you can log in. That's really the long and short of it there. So, yeah. So let's take a look at this config file. So what does the config file do? Well, the config file is like a configuration file that just you can put permanent configs in there, so you can actually add your username in there. You can do a whole bunch of stuff. And that'll essentially give you the ability to automate your SSH process a little bit. So in there you'll notice I have forward agent. That's specifically the one I want to talk about because it's important. So what does forward agent do? So in a lot of corporate environments or work environments, you'll have what's called a jump server, right? Which is a server that sits between your system and the actual network and sort of works as a gateway for your SSH setup. It's sort of like where most of the security for SSH will reside on your network. It's the entry point to your network over SSH. That's not to say that that's over the public internet or anything like that. A lot of these won't be network accessible. It's just, your team will hit this jump box and then they'll get to the systems behind the jump box via SSH again, right? So you'll SSH through that system to access remote systems behind it. So what does forward agent do? Well, when you authenticate to your jump box, sometimes you don't want to have to re-authenticate to all the servers behind it. What forward agent does is it copies the agent data from your local system over to the remote system and reuses it so that you can then authenticate automatically to the following systems. It basically automates the process of jumping from server to server so that you don't need to retype your password. Or worse, if you have a smart card or some other two-factor form of authentication, you don't want to have to redo that every single time you hit a new server. One, it probably won't work anyway, and two, it would be really annoying even if it did. So you use forward agent and it will forward that authentication mechanism from server to server to server so that you can then jump from system to system to system. And as long as your keys are in place and you've got proper access to said systems, you're fine and you can jump around as much as you want. So that's a really cool one, but you can do different things, like you can set up host names to use different pub keys. So you only want to use this specific key on this specific system and this specific key on that specific system. Maybe you want to set an alternative username for some systems. You can absolutely do that. I'm not actually going to show you that in there because that would take all friggin' day, so we're not going to do that. But what I am going to show you is you can man SSH, I think it's _config. And in here you can actually look at the various settings that you can use in that file. So you can see hosts, you can see match. I think there may even be an example. Let's do XAMP. So let's see. Sometimes there's examples at the bottom. Oops, not mark. Example. Let's do maybe like that. Nope, no examples. Sad panda. Okay, well, you can absolutely, go through this and you can see the various switches and stuff. I also recommend that you look, Google hostname or the SSH config files in the home directories of people. Just Google for SSH config, use your SSH config files, something like that, and you'll get good examples of what people have done. But you can set or use any of these particular switches in those in order to modify your SSH or automate your SSH so that you're not having to constantly use different switches on the command line to make it happen. However, you can absolutely use switches to point to what key you want, etc. and so forth if you want to use it in your SSH command line every time. Some people set up an alias to do it. They're doing it wrong. Just use a config file. Although that will work if you set up an alias, but don't do that. That's the wrong way to do it. Just use a config file. It's better. So the next thing I want to show you is there is a program called SAR, System Activity Report, and it is the hypothetical bit. I'm not actually going to talk about SAR that much, but basically what SAR does is it outputs. You can get SAR, by the way, by installing it via apt. You can do apt install. I think it's systat, apt search systat, I think, something like that. Not sysstart, systat. Maybe like that. Yeah, there it is. System Performance Tools for Linux. So if you install this program, you'll get a program called SAR on your system, and then you can use that to generate system activity reports, and it will show you like CPU utilization over time, and it's a good way to see like how your system's actually behaving. I don't actually have it installed on the system, and I don't intend to install it on the system, but hypothetically, if we wanted to get that system activity report off of that system and onto our main system, we could use SCP, which is the next command I'm going to talk about. There is a better way. So what we can do is to get a system activity report, you would type something like SAR and then like TACH A, and then you could point it at, I normally use a little p like that because it gives you pretty outputs for your hard drives. And then you would point it at var log, and I think it's SA, and then I think it's SA and then like a number. So it would be like SA12, for instance, and that would get the SAR file for the 12th of the month. And then you can use that to input, you can use that to understand what is going on your system. However, that's not always a good thing because it's a bunch of numbers and it's hard to read. There's a program out there called KSAR. It's a JavaScript it's a Java program, sorry. So it uses Java, and so it's universal. You can install it on anything, and you can use that, and you can feed it these SAR files into it, and it will generate like a pretty graph for you, so you can see your CPU utilization over time in a way that's more meaningful or that you can visualize better. And that's a pretty cool way to look at your system. But that SAR file is locked away on this computer on a remote server, and yes, I could go in and I could write that out to a file and I could SCP it across, but that is so much more complicated than I want. I want to take the lazy man way out because do everything lazy. It's so much more better, or it's so much more awesome, right? So what do? We do SSH, and then we do the user, right? So user, if your user is different, it doesn't have to be, but if it is, do that. That bit's optional, right? Remote. I'm just going to do remote for the remote host. I'm sure you all get it by now. And then you put this in quotes, right? And user redirect. And then you do remote remote.sar. So the file name there is completely arbitrary, right? So remote.sar is arbitrary. You could name it bigfile.whatever, or it doesn't matter, right? The reason I use SAR is just for my own sake. I like to know that it's a SAR file, so I use .sar. And the remote is the name of the host, so I know where the heck it came from. And that's pretty much what I do. Maybe you could add a date to it or something if you wanted, whatever your pleasure, whatever you like. So what's interesting about this command is it's going to SSH into user at remote. It's going to generate a system activity report, and it's going to redirect the output to a file called remote.sar. Here's the interesting bit, though. Remote.sar is not going to exist on the remote system. It's going to put it in the working directory of the system you are currently working on. So in my case, it would put it in .ssh, which is probably not desirable. So maybe put it in home. So move to home. You can also give it a path, so you can do like this, right? You can do tilde like that, and it will put it in home for you. That's perfectly acceptable too, and it will put that file on your local computer. So how cool is that, right? You get the SAR file and you get it out of your computer. You can do that with any file or generally any command. You can even go in there and you can say, I want to see free, or I want to see the output of this file, and I want to put it in, into this, redirect that output into this particular file. You can do that. If you leave off the redirection, it will simply print the output to your screen, but you won't be SSH'd into the remote system. It's a one-off, right? So you're in a way, this makes SSH sort of work like sudo. It's a one-off. You just use it for that one command, and then you're back to your normal system. So if you want to get information on your remote system, this is a really cool way to do it. If you want to get remote information on a lot of systems, look up and use Ansible. It's better. So anyway, that is how you would do that. Because none of that stuff exists or is real in this context, and all that was sort of hypothetical and for demonstration purposes only, I'm just going to quit that command and not actually run it. So the last thing you can do is SCP. SCP is called secure copy. It is a file transfer method over SSH. So essentially it's a way to send files between two computers in an encrypted method. You can also use it as a gateway. For instance, you can use it to send one file from one computer through your laptop or desktop or whatever you're working off of and into another computer. So you can actually send it across using your system as a bridge. That works too. There's also really cool methods of sending it remotely. So like if you have a jump box and you want to hit a system behind the jump box, you can actually do that. I'm not going to demonstrate that in this video, but I might do it in another video if somebody asks. So yeah, you can do a lot with SCP. So I'm going to show you some basic stuff that you can do with it. So the gist of it is you're going to do user at remote, right, and then colon path to file.txt. So SCP generally, for instance, takes two arguments. It takes the input file or the remote file that you want to get, so basically source, and then it takes destination, where you want to put said file. So this is going to move a file that user owns on remote, which is the host name or IP address of the remote system. The colon is the delimiter for the pathing, right? You're basically saying, okay, this is going to be the path, and then you give it the path starting with root all the way down. You can absolutely, if it were in your home directory, you could do this. That's perfectly acceptable, and it will get your home your home directory. For your destination, you could use a dot, for instance, if you wanted to go to your working directory. So in this case, that would be SSH. You could use any valid path. You could use a tilde if you wanted to go to home. If you wanted to go to opt, you could do that if you have permissions to write there. So you could also sudo this up and then write it there as root. That's perfectly acceptable. But note, if you do sudo, you're doing it as root, so you're probably going to use user. You're probably going to, this will become sort of less optional there, because I doubt root's going to be allowed to log into the remote system, and if they are, you need to contact whoever did that and tell them not to anymore, because that's incredibly stupid. But so essentially, that is a way of doing that, right? Where you can do that. But what's really cool about SCP is you're not limited to just this system. You could totally do this. User2 at other system :tilde, right? So what that would do is it would take file.txt in the home directory of the user at the remote system, and it would send it to user2 at other system in his home directory, or her home directory, provided it's a lady. And you would have the ability to copy a file from one server through your laptop to another server, so, or desktop, or whatever you're using, right? You get the drift. So that is how you use SCP in a nutshell. You can absolutely use the source as your system. So if you want to copy a file from your computer, for instance, like a file in your home directory, so you could do, let's actually go back up to home. Right, so if we wanted to copy a file in our home directory, so we did SCP, right, we could absolutely do mess.txt, like so, and let's say we wanted to SCP it to user at remote and let's put it in his home directory, right? So that would absolutely work. You could do that. Now it would send a file on your local computer to a remote server. So you may be wondering, how can I find out what files are on a remote system? Well, the best thing to do simply is to have another terminal up on the remote server, and you can just ls that server and find out, or use the pwd command to list where you're at and what the path is to the file, and then you can find out a little bit more about the specific, what's on the server and what you want to grab. But SCP is a quick way to manipulate files and transfer them from one server to the other. So it's a great, fantastic tool. You should absolutely be using SCP. A lot of people like SFTP or something like that. Personally, my preference is just regular old SCP. That is exclusively how I transfer files from one server to another in a Linux fashion. There's also rsync and other things like that. So if you're doing like major backups or really big things, you may want to look into rsync. I'm not actually going to go into rsync, but it is something for you to look up if you're interested. That is, if you're interested, spelled like this, RSYNC. It has a whole bunch of switches and things that you can use for archiving purposes. You can use that to transfer files between systems, or back stuff up or whatever. There are switches that allow you to keep or maintain file permissions and ownerships and all kinds of stuff. So I think that's like TACH for archive or something like that. Anyway, rsync is a good tool as well. So I think that should about wrap this up. I don't want to make this video too long. So thank you guys for watching. Hopefully I can get more of these things done soon, and you guys can learn more stuff. I hope at the very least someone learned something from all this, and yeah, I'll see you guys in the next video.